Hello everybody. Today I want to explain about one of my talk. Let me share my screen. Yeah, it's about Hyades tidal tails revealed by Gaia DR2. Today I want to explain about first introduction about highest tidal tails, and then finding the highest tidal tails, identifying the tidal tails, conclusion and reference. It's about one of the papers that I read, and now I want to give you a summary of that paper. First, I can say that the tidal tails of stellar clusters are an important piece of information on the cluster's kinematic evolution, the process of dissolution, and the impact of galactic gravitational field on the subsystem. Only tidals of massive clusters and dwarf galaxies we can discover. The most important of them is, the famous of them is globular cluster Palomar 5. Maybe I can ask that, what about the open clusters? About open clusters, until now, no one have detected any tidal tails related to open clusters. The reason of that is because open clusters mostly are in galactic disk, and in galactic disk we have stars and background of field of stars, and maybe we cannot detect them easily. And the other reason is possible collision with massive molecular cloud, that it can destroy part of the tails of the tidal tails. The tails mostly contains stars, so molecular clouds can pull out or push out the stars from the tails, so we cannot detect them. And about Hyades cluster, it is one of the, it is the nearest open cluster to our sun, and the distance of that is around 46 parsec, according to Gaia DR2 release 1, and it is around 47 parsec according to Gaia DR2 release 2. Finding the highest tidal tails, the scientists of this paper, they said that tidal tails can have 18 parsec length if it didn't destroy during the 650 million years by passing molecular clouds, disk shocking, or spiral arm passage. In the vicinity of a cluster, highest cluster tails reveal themselves as co-moving stars with space velocities close to the velocity of this cluster. They focus their research on a smaller volume and chose a sphere around the sun with a radius of 200 parsec. This should be large enough to contain a good portion of the highest tails if they still exist. In figure 1, you can see the velocity distribution of stars in tangential velocity plane, V parallel observation and V parallel prediction, and the V perpendicular observation. The 0 point here, the 0 point is the predicted value from the space motion of Hyades. The x-axis points in the direction of the convergent point. The units on the color bar are stars per 0.25 kilometers over a second. The box indicates the selection window that might belong to the tail. And you see here the leading tail and tidal tail. And trailing tail. In figure 2, in the left, you can see the distribution of the stars in the X and Y plane after the cut in the tangential velocity plane according to the situation in figure 1, as I showed you. The red circle indicates the tidal radius of 9 parsec, and the red arrow points to the galactic center. Right histogram of marginal distribution X. Green shows the histogram for Y larger than 35 parsec, and yellow represents Y less than minus 35 parsec. Identifying the tidal tails. In order to distinguish the tails from the background, we have to estimate and reduce the influence of isolated field stars that by chance obey the velocity restrictions in V parallel observation and V perpendicular observations. To explain physical overdensities, they therefore proceeded as follows. Around each of 6,895 stars, they draw a sphere with radius 10 parsec and counted the stars that fell into this sphere. They selected the spheres that were filled by 6 stars or more, corresponding to a minimum density of 1.5 cross 10 to power minus 3 stars per parsec. And finally, selected all stars that belong to at least one of these spheres, that they are 1,316 stars. In here, you see the figure 3, Hyades and the tidal tails. The figure shows the spatial distribution of stars in dense regions with at least 2.5 cross 10 to power minus 3 stars per parsec. From left to right, panels distribution in Y, X, and Y, Z, and XZ planes, stars selected in Gaia DR2 are shown as dots. In red, they plot the highest cluster proper. In green, the leading tail. In blue, the trailing tail. And in pink, all other stars in dense regions. The location of the predicted Hyades tidal tails from the model by Harchenko et al. Are indicated in the yellow in the background. And in figure 4, you can see MGVS GBP minus GRP from color absolute magnitude diagram of the Hyades and the tidal tails. The gray circles are the stars by Gaia collaboration, representing the cluster proper. The cluster stars selected here are shown as small red dots and are mostly identical with the stars. With the bubble-like stars, the green dots are stars from the leading tail, and the blue dots show the stars from the trailing tails. By conclusion, we can say that using the data from Gaia Data Release 2, they search for the presence of highest tidal tails in a sphere of 200 parsec radius around the sun. They found 501 cluster members within 2 tidal radii, 18 parsec, from the cluster center with a possible field star contamination of 7. A leading tail, tidal tail extending up to 170 parsec in the direction of galactic rotation with 292 stars and 36 contaminants, and a trailing tail up to 70 parsec from the center of the cluster with 237 stars and 32 contaminants. And they found 5 white dwarfs. White dwarfs are found in the tails, and found a moving group some 150 parsec from the sun, near the border between the constellations Sagittarius and Corona Australis. And you can see here the reference of this paper. It is from this paper. And thank you. Thank you for your attention and see you next time. Bye.